Hello, and welcome to the Student Support Services Program's Workshop Series. The following is an educational recording produced by tutors from the Student Support Services Program at the City College of New York under the supervision of sound engineer, recording engineer, mixing engineer, mastering engineer, producer, arranger, composer, Linwood Fitts. This recording accompanies a PowerPoint presentation by the same name. Please do not post or share these files, which remain the intellectual property of the Student Support Services Program. To begin, open the PowerPoint presentation, and whenever you hear a turn to the next slide. Here is the workshop presentation, Balancing Chemical Equations, created by Malek Ayoub, developed by Chen and Selina Zaman. Here is Miss Selina Zaman.
Hi everyone, this is Selina Zaman, and today we're going to be talking about chemical reactions. A chemical reaction occurs when we add two or more different chemicals and we form a different product. So when we write down a chemical reaction in an equation form, that's going to be called a chemical equation. So a chemical equation is a symbolic representation of a chemical reaction in the form of symbols and formula, where the reactants are going to be given on the left-hand side and the products are going to be given on the right-hand side. So whenever you start with any kind of chemicals, you have to write those down on the left side, and everything that's going to be produced after the reaction is over is going to be on the right-hand side. So if I add zinc and iodine, I'm going to get zinc iodide. So my two elements which are separate that I start with are going to be called my reactants, and those are going to be on the left side. And whatever I get after the reaction is done, it's going to be on the right side. And when a chemical reaction occurs, the bonds are going to be either formed and broken down between atoms and molecules. So if I start with iodine and zinc, as you can see on the previous slide, all the bonds in the zinc atom are going to be broken down and iodine atoms are going to be broken down. And then when they form zinc iodide, all the bonds are going to add together and it's going to create a different product. And it also involves chemical changes in the matter, forming new substance with totally different properties and energy. So for example, if I say that sodium chloride, which is a table salt that we use in cooking or when we eat something, sodium is a metal and it's a highly reactive metal, and chlorine is a very toxic gas. It's a green gas, but when they are reacted together, they're going to form table salt, which is a totally different thing. It's not toxic and it's not a metal either. So what this means that every time two different substances are reacted together and they form a new product, the properties are going to be totally different and it's going to be a new properties. Now, if I add carbon and oxygen, and we are going to get carbon dioxide, so I can say that C plus O2, because oxygen is going to be a diatomic molecule. So I'm going to get carbon dioxide. So chemical equations show the conversion of reactants into products. So two of the chemicals, two different elements are reacting and making a different product. The plus sign is going to represent the two chemical substances that are being combined, and the arrow sign is going to represent that it's being formed or yield. So you can say that chemical equation is going to be carbon plus oxygen react to yield carbon dioxide. That's when you say it, that's how you're supposed to read it, a chemical equation. Now, if I have aluminum and oxygen, it's going to form aluminum oxide. And the number, as you can see from the slide in the front, it says 4Al. It means 4 aluminums, 3 O2, 3 oxygens, and in the end, the product is 2 aluminum oxide. So always the number in the fronts are called stoichiometric coefficient. It tells you the quantity or how much or how many of the same element that you're using in the equation. And the letters that you can see in the brackets, they tell you what the physical state of the compound is. So for example, in this equation, S is a solid. So my aluminum is in solid form. My oxygen is in the gas form. And the product that I get after the reaction is done, it's going to be in solid form. So my aluminum oxide is a solid, is going to be in solid state. So the symbols that we use in the equation, stands for solid, L stands for liquid, G stands for gas, and AQ stands for aqueous solution. And if there is any change in the temperature, it's going to be shown by delta. One thing to remember is that whenever you write down the state of matter, it always has to be in lowercase. So small s, small l, small g, and small a and q. Remember from the previous slide when we said conservation of mass or matter? It's the principle that was discovered by Lavoisier, who said that like energy cannot be created nor destroyed, the law of conservation of mass or matter tells us that in a chemical reaction, any reaction, matter is neither created nor destroyed. So one or two molecules or substance are going to be added together to make a different substance, but nothing is going to be created nor destroyed. So that because of this principle of conservation of mass or matter, the equation must be balanced always. So you cannot have more of one element or one substance on one side of the arrow and less of that exact substance on the other side of the arrow. It always has to balance. So when you add coefficients, so there is a difference between the coefficients and the subscripts. Every number that you have seen on the previous slide in the front of the elements are the coefficients, but the numbers in the bottom, for example, in one of the previous slides, when you see that aluminum oxide, it says Al2 and O3. All the numbers that are at the bottom, those are my subscripts. But 2Al2 and O3, the 2 in the front of the aluminum oxide is my coefficient. So 2 is my coefficient, and the 2 after Al is one of the subscripts for aluminum oxide, and 3 after O and the bottom is the other subscript. So there is a difference between the subscript and the coefficient. The coefficient tells us the amount or the quantity of that element or the substance that we are using, but the subscript tells us what type of molecule or compound we are using. So for example, if I say H2O and if I say H2O2, there is a difference between H2O and H2O2. H2O is water and H2O2 stands for hydrogen peroxide. So just by adding the extra 2 at the bottom of oxygen, I can say that this substance is hydrogen peroxide and not water. But if I have different numbers in the front of water or hydrogen peroxide, I could say that this substance I am using a different amount of this substance, but adding a different number tells you that the compound has totally changed. So every time you balance an equation, you always have to remember that you can change the coefficients to balance the equation and the compounds on both sides of the arrow, but you cannot change the number at the bottom because it's going to change the subscript, and thus it's going to change the compound itself. So the next slide tells us the subscripts versus coefficients. It just tells you everything that I just went over. So in the chart, you can see that C means carbon, and it's shown by one black circle. It's a valence circle, so one atom of carbon. If I have one of the red circle, it tells you one atom of oxygen. They're just using different color to differentiate the two different elements. Now if I have O2, it means I have one molecule of oxygen that has 2 atoms of oxygen in it. If I have one C and one O together, it says that one molecule of carbon monoxide has 1 atom of carbon attached to one atom of oxygen. If I have CO2, it tells us that one carbon is attached to two atoms of oxygen. On the last line, where it says 3 CO2, it tells us that I have 3 molecules of carbon dioxide, and each of the carbons are attached to 2 oxygens. So as you can see, the subscripts tell you how many atoms of a particular element are in the compound, but the coefficient tells you the amount or the number of molecules in the compound. So that's the difference between the subscript and coefficient, and you always have to remember that you can change the coefficient number to balance the equation, but you cannot change the subscript. Now, the steps to balancing equation. Step number 1, you have to write out the correct formula of the reactants and the product. The second step is going to be to count the number of atoms for each element on the left side and compare them with the number of the atom on the same element on the right side. Step number 3, determine where to place coefficients so that the left side has the same number of atoms as the right side for each element. Step number 4 is to check your answer to see if the number of atoms on both sides of the equation are now balanced and the coefficients are in the lowest possible whole number ratios, or you can say that it has to be reduced. So let's go to the next slide and let's do an example. Let's figure out the chemical equation for the following example. Find out the stoichiometric coefficient to balance both sides of the equation and state of matter. Take 5 minutes to solve this equation. You can pause the audio and take 5 minutes to solve this by yourself, and then you can come back and resume and check your answers. Now, my equation is H2 plus O2 it yields H2O. I have blanks for the coefficients and a blank for the state of matter. So when we start, this formula, this is the way I use this. This is one of the methods that we are going to be going over today. So this first method, this is the way I solve this balancing equation problem. So I write down what elements I have from the equation, and I make 3 columns. So the first column says reactants, which are the elements from the left side of the arrow, and the third column tells you the product. So all the elements from the right side of the arrow. And in the middle, I just write down what the elements are. So the first line says hydrogen, and on the left side, I have 2 of the hydrogen, and on the right side, I also have 2 of the hydrogen. So I'm going to write those 2's down. For oxygen, on the left side, I have 2 oxygens, but on the right side, I only have 1 oxygen. So this is the part that needs to be balanced. So since I can only change the coefficient, so on the right side, since I only have 1 oxygen, if I multiply that 1 by 2, my oxygen is going to be balanced with the left side. So what I'm going to do is that I'm going to write down a 2 in front of H2O to balance my oxygen. But when you write down that 2 as a coefficient in front of H2O, you can see that immediately when you write down that 2, your H also changes. The number of hydrogen you had before, now it's going to be changed after you wrote down that 2. So 2 on the subscript for H in the H2O. In front of the coefficient, you have another 2. So 2 times 2 gives you 4. Now you have 4 hydrogen on the right side, but on the left side, you have 2 hydrogen. So in that case, you also need to balance the hydrogens. Now what you can do, you can go back in the equation, and on the left side, you can multiply the H2 by another 2. So you can write down a 2 in the front of the H2. So you're going to have 2 times 2, 4. So now the equation is balanced. So the answer is going to be 2H2 plus 1O2 goes to or yields or produces 2H2O. Now you can see that you have 4 hydrogens, 2 oxygens, and on the left side, and in the end the product has also 4 hydrogens and 2 oxygens on the right side. Okay, before we go to the next slide, there is one thing that you have to mention all the phases of matter in the brackets. So my H2 is going to be gas, my O2 is going to be gas, and when H2 and O2 are reacted together forms water. So water is a liquid. So there's going to be L in the bracket. So the next slide, it also tells you that H2 is a gas plus 1 O2, or you can just write O2. If you only write O2, it's gonna be said as there is 1 in the front as a coefficient, goes to or yields to H2O. Now, as you can notice that there are 2 H2s on the left side and 2 molecules of water on the right side, but for oxygen I have only 1 and as a coefficient. Why is that? So if you draw the picture, you could see that one of the hydrogens is going to be attached to one side of oxygen and another hydrogen is going to be attached to another side of oxygen. So each oxygen is going to be attached to 2 different hydrogen atoms. In that way, we get one of the water molecule. And on the next step, the remaining oxygen atom is going to be added with 2 more hydrogen atoms to form the second water molecule. So in that case, as you can see at the bottom, 2 H's are attached to 1 oxygen, and again 2 H's are attached to another oxygen. So I get my 4 H's and I get my 2 oxygens to produce 2 molecules of water. Now the next slide shows you another technique to find out the equation, balancing equation. So if you're good with the previous technique, you can use that one. But if not, this is an algebraic method that you can use. If you're good in math, you can use this technique. It tells you place an unknown coefficient or variables in the front of each molecular species. So my equation is C4H10 plus O2 goes to CO2 plus H2O. So I can write down X in front of C4H10, Y in front of O2, Z in front of CO2, and W in front of H2O. All these 4 letters, Y, X, Y, Z, and W, are going to be my unknown variables, or the coefficients that I need to find out to balance the equation. Now, to create the equation using the variables for balancing for each element, I can say my carbon is 4x equals to Z. Okay, so if you go back to the equation, you can see that it says C4, and in front of that, I put down the coefficient x. So in that case, I'm gonna multiply the coefficient with the subscript, and that's how I get my 4x equals to Z. On the right side, you would be able to see that carbon has a Z in front of it on the right side of the arrow. In the carbon dioxide, you see that there is CO2, but in front of the CO2 there is a Z, and the subscript for C in here is 1 because there is nothing. So 1 times Z is Z. So what this process tells you that you take the subscript for each of the element, multiply that by the coefficient, and equal that to the right side of the coefficient of that same element multiplied by that subscript. So for carbon, it's going to be 4x equals to Z. For my hydrogen, it's going to be 10x equals to 2W because I have C4H10. So H has a 10 in the subscript, but in front of that C4H10, there is an x for my coefficient. So I simply multiply 10 and x. I get 10x. On the right side, I'm going to get 2W for my hydrogen. For oxygen, on the left side, it's 2y. And on the right side, I have oxygen on both of the different molecules. I have oxygen with carbon dioxide, and I also have oxygen with my water. So I'm just going to add the 2 different variables. So my 2y is going to be 2z plus w. So I get Z from my carbon dioxide, and there is 2 at the bottom as a subscript for oxygen. I multiply those two and add that with W on the next from the next molecule of water. So my oxygen is going to be 1 times W. So 2Y, in the end, 2Y is equal to 2Z and W. The third step is going to tell you have to substitute one of the variables with 1 and solve for each other variable. So if you set X equals to 1, you can find out that carbon is going to be 4 times 1 equals to Z. So my carbon is going to be 4. So Z equals to 4. The next one is also for hydrogen. I have 10X, so I just substitute 1 in the place of X, and I get 10 equals to 2W, so my W is going to be 5. Now for the last one, I just substitute that 4 and 5 from the previous 2 steps into that equation, and I get Y equals to 13 divided by 2. Now, the next step is going to be you're going to have to replace all the coefficient variables with the solved numbers. So in the end, my equation is going to be 1 C4H10 plus 13 by 2 O2 yields 4 carbon dioxide or CO2 plus 5 H2O. Now, when you can see that I have 13 divided by 2, from the previous slide, well, 2 previous slides, yes, if you go back to the previous slides, you can see the last step was the coefficients are you have to check your answers to see that the coefficients are in the least possible whole number ratios. So when I have 13 divided by 2, I have to change this number because it's not in the least coefficient form. So I have to express all the coefficients as they're in whole number. So I'm going to multiply the entire equation by 2. In that way, I'm going to get 2C4H10 plus 13O2 yields 8CO2 plus 10H2O. Let's go to the next slide. So one of the suggestions that's going to help you with any of the techniques that we have spoken so far, we have to work with one element at a time from left to right. You should never start with a couple of elements together to balance when you have to balance the equation, because as you remember from a couple of the equations in the previous slides, when we change one number or one coefficient to balance the equation, if that substance is attached to a second substance, the second substance it's going to change automatically. So you should always work with one element at a time. Always balance hydrogens and oxygen last. If everything is balanced except for oxygen, and there is no way to balance the oxygen with a whole number, double all the coefficients and try again, because all oxygen is a diatomic element. Also hydrogen and nitrogen, these are diatomic elements. So whenever you have any diatomic elements, try this last step. Now take 5 minutes for the next slide. You are given an equation. It says blank Al, which is in solid form, plus blank bromine to in brackets says in liquid form, yields blank Al2Br6. It's in the solid form. Take 5 minutes, pause the audio and try to do it by yourself, and come back and check your answers. Now, if you go by the first technique, you can just make 3 columns, and in the middle column you can write down the elements that are in the equation. On the left side, you can put down all the coefficients that are on the left side of the equation, and on the right side you can put down all the element numbers that you already have. So for this equation, I have 1 Al on the left side, but 2 Al from the right side. For bromine, I have 2 bromine from the left side, but 6 bromine from the right side. So now if you want to balance this, what you have to do, you have to multiply aluminum by 2 to get 2 aluminums on both sides, and multiply bromine by 3 on the left side so that you can get 6 bromine on both sides. So the final answer is going to be 2 aluminum plus 3 bromine goes to 1 Al2Br6. Now let's go to the next slide. It's another equation that you have to balance. Take 5 minutes, pause the audio, and try to do it by yourself and come back and check your answers. So for this one, again, if you want to use the first technique, you can write down all the elements that are being used in the equation in the middle column. So I have C, H, and O. On the left side of the equation, I have 3C, 8H, and 2 O's. On the left side, I have 1C, 2H, and 3 O's. Now, if you want to balance this, what you have to do is you have to change carbon first. As you remember from the previous slides, we always balance hydrogen and oxygen in the end. So we start with carbon. If I write down 3 in the front of carbon dioxide, on the right side, I get my carbon changes. So I get 3 carbon on both sides. So at the same time, my oxygen also changes. So if I put down a 3 in front as a coefficient in front of carbon dioxide, I get 3 carbons, but at the same time, 3 gets multiplied by 2 from the subscript of oxygen, and it becomes 6. And for water right next to it, which is water is added in the reaction in the product side, I have 1 oxygen. So my oxygen changes from 3 to 7 now on the right side. Then you have to change the oxygen also. So if you write down a 4 in front of a water as a coefficient, your hydrogen is going to be changed. So previously you had 8 hydrogen on the left side. Now if you write down a 4 in front of water, 4 times 2 from H2O, you get 8 hydrogens in the front on the product side. In that way, oxygen changes again. Now you have 10 oxygens because you have 3 times carbon dioxide. So you have 3 carbon dioxide and 4 water molecules on the product side. So 3 times 2 from carbon dioxide, you get 6 oxygen, and 4 times 1 from water. Since I don't have any other subscript at the bottom, it's going to be 4. So 6 plus 4 is 10. My oxygen changes again. Now I have to balance my oxygen and change the coefficient on the left side for oxygen. So if I write down a 5 in front of O2, 5 times 2 from the subscript of oxygen, I get 10. So now my oxygen is also balanced. So the final answer is going to be 1 molecule of C3H8 plus 5 O2 yields 3 CO2 plus 4 of H2O. The next slide gives you another equation. So what happens in some of the exams, the professor is either gonna tell you the element name or the compound name in the chemical equation. You have to know how to write the chemical equations down and how to write the compound down. That's a different chapter that you're going to be learning from. So in this question, you have sodium phosphate plus iron oxide yields sodium oxide plus iron phosphate. So this is going to be the equation. Try and see if you can figure the equation by yourself. Take 5 minutes, try to solve this problem, and come back and check your answers. So my equation is going to be, I'm going to start with blank. Na3PO4 stands for sodium phosphate plus blank Fe2O3, which is my iron oxide, yields blank Na2O, that's my sodium oxide, plus blank FePO4, that's my iron phosphate. So let's use the first technique. Make 3 columns. In the middle column, we're going to write down all the elements that we are going to be using. I have Na P, O, and Fe. So on the left side, I have 3 sodiums. On the right side, I have 2 sodiums. For phosphorus, I have 1 on both sides. For oxygen, I have 7 on the left side and 5 on the right side. Iron is 2 on the left side and 1 on the right side. Now we are going to start changing and the coefficient so that we can balance the equation. So if I write down a 2 in front of sodium phosphate Na3PO4, my sodium is going to be changed from 3 to 6 on the left side. And if I write down another 3 in front of sodium oxide on the right side, which is Na2O, and I write down a 3 in front of it, I get a 6 for sodium also. So when I write down 2 and 3, I balance my sodium, but at the same time, my phosphorus, the number of phosphorus changes on my left side. So my phosphorus becomes 2 from 1, and also at the same time, my oxygen changes. Oxygen becomes 11 from 7. On the right side, when I changed my sodium oxide coefficient from there was nothing, and I wrote down 3. So if I add all the oxygens on the right side now, I get 7 oxygens. Now for the last one, iron phosphate, if I write down a 2 in front of iron phosphate, my number for oxygen changes, my number for iron also changes, and the number of phosphorus also changes. So all of now, after writing down all these numbers, all these coefficients, all of the elements are now balanced. So the final answer is going to be 2 Na3PO4 plus 1 Fe2O3 yields 3 Na2O plus 2 FePO4. That is going to be your final answer. Thank you very much for watching and learning.
This concludes the presentation. Thank you for listening, and we wish you all success in your studies.